Hi friends, here is a simple problem based on logical reasoning of functions. This function f is an 1 1 function, domain xyz and range 1 2 3. Okay, 3 is to 3. Now we are given three statements. F of x equal to 1, f of y is not equal to 1, f of z is not equal to 2. And it is said only one of the following statements is true. If that is the case, what is f inverse 1? Now, one of the statements is true. That means either this is true, or this is true, or this is true. Let us take all the three cases and see what we can map, how we can map this xyz to 1, 2, 3. Okay. First, let us assume f of x equal to 1. This is true. Okay. Then what will happen? X will be mapped with 1. Okay. And these two are false. F of y is not equal to 1. This is false. That means y not equal to 1 is false. That means y equal to 1 is true. Right. Now f of z is not equal to 2. This is false. What does that mean? What is true? Z equal to 2. So clearly this is not 1 1. 1 1 means x y z should be mapped to 1 2 3. This is not 1 1. So f of x, this is true and this is false. Here f of x equal to 1 is true. This condition is not helping us. Okay. Now let us assume this is true. F of y is not equal to 1. So y can be 2 or 3. Okay. This is true. Now this is false. F of x is 1 is false. That means f of x is not f of x is mapped to 1 is true. That means f of x equal to 1. The statement is false. What does that mean? X is mapped to 2 or 3. What is true? And is z is mapped to true. This statement is false. What is true? That means z to 2 is true. Okay. So now again, this is not 1 1. Here we are taken f of y is not equal to 1. This statement as true. When we take second statement as true and remaining 2 as false, we are able to map like this. And here also this is not 1 1 because 1 is missing here. Right. When f of y is not equal to 1, that means y can be 2 or 3. F of x equal to 1, this is false. That means f of x, if this is false, then f x can be 2 or 3. Right. Z is not equal to true is false. That means what is true? Z equal to 2 is true. Okay. So this is also not satisfying. Let us take the third case now. Third case, Z is not equal to 2. That is true. That means Z can be 1 or 3. Okay. Now x equal to 1 is false. Or y not equal to 1, this is false. What does that mean? Y equal to 1 is true. Y not equal to 1 is false. That means y equals to true. Okay. Now z is not equal to 2 and y is already 1. So z can be z can be 3. Now x equal to 1 is false. This is false. That means x can be 2 or 3. But z is already 3, y is already 1. So x is 2. Right. So x, y, z, they are mapped to 1, 2, 3 in this case. So this is a 1, 1 mapping. This is 1, 1 mapping. In all the other cases, see in this case 3 is missing. In this case 1 is missing. But this is the only case when we assume the third one as right and the other two as false. It is giving us 1, 1 mapping. So what we have done, z is not equal to 2. What does that mean? Z can be 1 or 3. Okay, and y is not equal to 1. This is false. That means y equal to 1. This is true. We are able to establish what is uh, y. Okay, we are able to establish what is f of y in this, and then x equal to 1 is false. What does that mean? X can be 2 or 3. X can be 2 or 3. So when y equal to 1, z has to be 3 because 1 is already taken, and x can be 2 or 3. Z is already 3, so x has to be 2. Right, guys? So f inverse 1 is actually y. This is the only condition that is satisfying. Right? If this statement is true and remaining two are false, we are able to establish a one-to-one mapping. Very simple problem based on logical interpretation only. Right, guys? Thank you.